because we're in love. Okay. So, it is time to start gathering up all of the loose ends and getting ready for a test on Thursday. So we're going to review for the rest of this period. We're going to review next time, and then we're going to take a handy-dandy test. So, get your review sheet out. There's a lot of stuff on it. And if there's a star, that means you need to use a calculator on it, or may use a calculator on it. If there's not a star, we're going to try to do it without. Sometimes I miss them, so you'll see. But let's jump in and go with this. So, who sees something on the review sheet that we need to start with? I'm going to keep track of these. Anybody see one that we need to start with? Yeah. 11O. 11O. That sounds like a lot. 11O. Alright, so the first thing I need to do is figure out what my rotation matrix is for 120 degrees. Alright, so who remembers? Gotta know this. Who remembers what the rotation matrix is? Yes, Tess. It is. So for us, it would be cosine 120, sine 120, negative sine 120, and cosine 120, just like Tess said. So note, this is not a calculator problem, so I better figure out what the cosine and sine of 120 are. I don't actually happen to have them memorized, which is possible. It's absolutely possible you have these memorized. I don't. So I'm going to draw a picture. I hope this is all ringing bells, guys. This is a part of your life forever. What's missing? A negative sign right here. That could be bad if you forgot. So remember, if your triangle is not in quadrant 1, then something is going to be marked with a negative. All right, so here we go. So what is the cosine of 120? Negative 1/2. And what is the sine of 120? Root 3 over 2. So I'm going to take my matrix. What am I doing? This is, so it's C, matrix C. So I'm going to take my matrix, which is 2, 0, 3, negative 4. And what am I going to do with it? Multiply it times my transformation. Can I multiply? Yeah. Because what's the rule? Just a little back review here. What's the rule for multiplication? So this is a 2 by 2 and this is a 2 by 2. They do not need to match, but these have to match, right? And the answer is going to turn out to be another 2 by 2. Now I made it a little bigger because I'm going to have some radical stuff going on. But this is going to be, there's going to be a number here, and a number here, and a number here, and a number here, right? So, to get that number, I'm going to take this row times this column. So I've got my 2 and my 0, a negative 1/2, and a root 3 over 2. I add them together. Negative 1, that worked out nicely, negative 1. Then my 2 and my 0. Negative root 3 over 2. Negative 1/2. Negative root 3. first row. Please stop me if I make an arithmetic mistake. All right, now I'm ready for the second row. Times the first column. Now those are not going to add. They're going to have a common denominator, which is 2, but it's going to be negative 3 minus 4 root 3. Now, if you wanted to write that as negative 3 halves minus 2 root 3, that would be okay too. I left it with a common denominator, but you could certainly separate it. You can separate it if you want to. And then what's that? Negative 3 root 3 plus 2, or separated. Actually, that would be plus 4. Sorry. Yeah, is that better? That one's okay? All right, Lily, got it? Yeah. And the angle could be anything. I mean, this one happened to be 120, but it could be anything. If it's not special, then you would need a calculator to do it. Like if it were 119 degrees, you'd use a calculator, but do the same thing. All right, who else has a question? Yep.
Can you do 11p?
11p. Reflected across same matrix, so that matrix right there, but we're reflecting it across the line y equals x. So it's kind of the same thing, except we need to reflect across the line y equals negative x, so we need a matrix for that. It's not a rotation. And again, I'm not going to tell you what these matrices are, but we know how to figure it out. What's the identity? What's the identity matrix? That's the matrix that changes nothing. What's that? 1, 0, 0, 1, right? That doesn't change anything. What happens when we change the signs on, let's say that one, if we change the sign on the x, this would be the, think about me, I'm 0. If you change the sign on x, you're reflecting across the y-axis. So that would be a reflection across the y-axis. Similarly, this would be across the x-axis, right? So what are some other things we did? What happens if we take the x and the y and switch them? What's that? That's the reflection across y equals x. It turned y into x. Now that is what we want to do, except we want them to be opposite. So we're going to take this, which is the reflection across y equals x, and make it negative. What is it if you take the original matrix and make them negative? What's that? That's a reflection across the origin. That takes positive, positive and makes it negative, negative, but doesn't do any switching. Right? So this is the one we want. Right here. This is the one we want. So that's the matrix we want, and our given matrix was the same one as last time. Oh, yeah. All right, so what are we coming up with here when we multiply? What do they got?
0, 0.
0, 0.
It's like, no, it smells like a woman.
Negative 2.
4.
Positive 4. Negative 3. Okay, so I want you to just look at something real quick. that guy right there, think of him as the point 2 comma 0. What did he become?
0, -2.
So what happened? They switched and became negative. Isn't that what we wanted to have happen? Yeah. All right, is that okay, Sydney?
Yeah.
Okay. Who else? Anything on the review sheet? There's a lot, guys. Let's go.
14.
Write the equation of the parabola. All right, now, let's pause a moment. What does the equation of parabola look like? It's an x squared. So written out in like standard form, y equals ax squared plus bx plus c. Think of your quadratic formula. Isn't that the way your quadratics look? Now, I don't know, I got some parabola out there, this equation, and the point 2 comma 6 is on it, which means that if x is 2, y is 6. Does that make sense to you? And if x is 4, y is 31. And if x is -2, all right, be careful, so that's still 4a minus 2b plus c. Y is 4. So what have we generated here? A system of 3 equations, 3 unknowns. Now, I have this on the no calculator part. Could it be a calculator problem? It absolutely could be. And you would, either, I don't know, Gauss-Seidel reduction or something, set that up. What would you do though if we're not going to let you use a calculator? What are some strategies you can think of to do? You can make a matrix out of it. You don't have to. There's no directions that say use a particular method. So remember, those are the equals numbers. So if you're going to put this into a matrix, probably do 4, 2, 1, 6, 16, 4, 1, 31, and 4, -2, 1, 4. All right, so Leah, this was your idea. What do you want to do now? I made it a matrix. Got my A's, B's, and C's. Ready to go. What do you want to do with it now? She wants to do Gaussian elimination. Now, the directions don't say I have to use Gaussian elimination. So there isn't really a rule that says this has to be a 1. Is it okay for it to be a 4 in this problem? Yes, and it'll make it easy to get those zeros. So I'm just going to go ahead and leave that 4. There are no directions, so there are no rules. So I need to make this a 0, so I'll multiply the top row by -4. And I get 0, -4, -3, 7. Don't let me make a mistake. Is that okay with everybody? Oh, I think I have quizzes to turn back. Yeah, I do. Okay. And then I'm going to multiply the top row by a negative and add it, so I get 0. Oh, wow, this is so cool. I get 0, -4. Oh, this is amazingly cool. 0, -2. Now, why am I so excited? Remember, there were no directions. I can solve this however I want. Why is this? I'm done. I'm done. What does this bottom row tell me? I mean, it's not like normal, but it says y -4, actually b, equals -2. So b equals 1/2. And then what does this row say? -4 times 1/2 minus 3 c's equals equals 7. Are you following along? So negative 2 minus 3c equals 7. So negative 3c equals 9. C equals negative 3. Don't let me make a mistake. Am I doing okay? What?
What is C? Wait, yeah, C. No.
Am I right or not?
Yeah, you're
Okay.
right. That was.
All right, and then the top row, 4a plus 2 times a half plus negative 3, so minus 3 equals 6. So 4a plus 1 minus 3, so minus 2 equals 6. Did you get 2 for A? So what was our job? Write the equation of the parabola. Go back to the beginning. Y equals 2x squared plus 1/2 x minus 3. And there's the equation of your parabola. Reminds me of a homework problem. Some of you, and maybe I've handed it back, maybe I haven't. Tomorrow I'll hand back everything and we'll review those things too, or maybe here in a minute. But it was a cubic polynomial. And some of you did it this same way. Well, you do it the same way, but a cubic polynomial would have what format? Y equals ax cubed plus bx squared plus cx plus d. So some of you only generated 3 equations because you were using that format. That's wrong. I mean, the process is the same. But if it's a cubic polynomial, it looks like this. Okay? Anyway, all right. What else? Good question. Good. I'm glad we did that. By the way, we didn't have to do it the way she wanted to, but it sure did work out nicely. So that's great. All right. One more, and then I'll hand back some papers. What else? Lucy?
6.
Can't hear you.
6.
6? Sketch this thing. All right, so what do I have to do first? I have to factor everything. So I've got 2x squared minus x minus 6, which is 2x minus 3x plus 2. All right, there's my top. And my bottom is x plus 4, x minus 3. Okay, hopefully I factored that right. All right, well, what do I notice then about this?
They cancel.
So that means I'm going to have a hole in my picture, and the hole is going to be at the point where x is 3. Because that's the factor that I canceled out. Okay. So now what? Plug 3 in, what do I get? If I plug 3 back in, this is what I'm graphing now. This is what I'm graphing. If I plug 3 in, I get 10 over 7. So 1, 2, 3, 1, 2. There it is, 3 comma 10 sevenths. That's where the hole is in my picture. All right, what else do I have in my picture? This is what we're graphing. Focus your little eyeballs right here. What do we got? What? Vertical asymptote at x equals -4. Yep, because that's where I'm undefined. All right, what else do I have? Horizontal asymptote at y equals 2. That's the limit of the function, horizontal asymptote. Looks like if I let x be -2, I'm going to get a 0. It's called an x-intercept or a 0. And if I let x be 0, I get 1. Lucy, you with me so far? Okay, well, I'm done. Now I just have to graph it. If I don't know what to do, I'll set up a T-chart, plot a few more points. But I think I have a pretty good feeling for what this looks like. What about you? Does that make sense to you? But we're not done. That's only half of the picture, right? Where's the other half? Up in the corner, right up here. That's exactly right. All right, so what I'm gonna do now is turn back any homeworks and quizzes that I have. And then tomorrow you will ask questions about homework and the 7-5 will be due Wednesday. 7-5 will be due Wednesday. So guys, your job for tomorrow is to come prepared with questions. Do not make me mad by coming in here and staring at me. I need you to come with questions.
Yeah, since it's really hard. I really a little freshman left. I couldn't figure out the self-description.
What class was it? Visual Basic? That's Visual Basic.
On Windows. Cybersecurity is the government. It's pretty. Is it not cybersecurity?
Government's like,
like a horror.
the government? I could, if I could, I'd be like,
We just watched Agent Conan Banks and now that's CIA.
I'd be like, that's how it out. I probably do private. They get paid all the time because companies get like,
I mean, it's just like this. Yeah.
yeah, I think it's
I feel like you're in Madeline.
yeah, I don't think she likes it.
She like tested it.
We'll take care of all your questions tomorrow.
She said she could, the program's about one out of something.
She's like, oh, I'm gonna do this.
Thank you.
Yeah. Can I get there and like an hour? Oh no, honestly. Positive 3. I corrected it later on in the page, I just kept trying.
Okay.
That's it.